Dune, but I was working on this visualizer, and so here is I just found a random transaction to MasterChef. This was a withdraw transaction, and so you can kind of see what happens. Someone calls this contract, which then invokes the solidity function withdraw on MasterChef. MasterChef then goes and updates the pool, which involves figuring out the multiplier using safe math. And then ultimately what happens is MasterChef figures out how many tokens it needs to create. And then it goes and it reaches out to the SUSHI token contract to mint tokens. And then what happens here? More safe math. So this is SUSHI token, and then SUSHI token then comes back and it gives those tokens back to the MasterChef, and then MasterChef goes and mints. Let me see one second. I have a better diagram. But you see, well, the conclusion was that each of these mints, one of these mints is for the dev share and the other mint is for the issuance. I'll pull up one.
Do you guys know what move delegates does?
Yeah, here, let me get a better one sec. So this is a deposit transaction. And this has the variables decoded. So I'll just make this smaller and then zoom in. So you can see this person, a little bit bigger. This transaction was depositing to the pool number 11. I don't remember which pool that is, but this amount, whatever that is. And so this is what happens. Notice that on the deposit and the withdraw, this update pool happens regardless. And so what this update pool does is this is the issuance, right? We figure out, update pool figures out how many tokens it needs to mint. And then you can see it actually does this minting, and it mints, which one's bigger? Yeah, so this is the dev share address. This was Nomi, and this number is 1/10 of this number. This C2 address is MasterChef itself. So this first mint, you can see, gets sent, 9% of the tokens, the new tokens, are sent to Nomi themselves. Move delegates, yeah. So what does move delegates do?
Move delegates is the concept of compounds where you can delegate your votes to another address. If you look at the SUSHI token itself, SUSHI token has two concepts in it. One's the delegate concept, so you can delegate your votes, and it has the checkpointed balances as well, which keeps a track of which token has been moved when, which serves to do like block comparisons when they're picking, counting the amount of votes in a DAO.
Yeah, so I guess I don't understand why move delegates happens. Sorry, those are not going away for some reason.
Was source and destination rep 0 address. So I'm not quite sure what it's delegating to.
Yeah, why is it moving the delegates to from 0 to 0? I don't understand.
Probably because there was no delegation required for this particular transaction, or this particular user chose not to delegate the token to anyone.
Right, here, let me reopen this. I need to stop selecting things. Maybe if I just turn on markup.
It's interesting. You can, if you look at the code, mint called move delegates of address 0 because they just been minted to delegates 2. So
Ideally, the 2 should have been,
Oh, the 2 is going to be 0 because the address 2 hasn't delegated to anyone.
right.
So yeah, because if 2 had a delegate, this is the moment where the delegate structure would be updated. So it doesn't do a special case. And regardless of 2 has something delegated or not, it moves delegates.
Oh, I see. So if 0xF9 had previously delegated, this would
Yes.
reset? I see. Okay, so that's why it's necessary during minting.
Yep.
And then here, the same thing happens. We mint 10 times the amount of tokens, and those get sent to MasterChef itself. And that's updating the pool. I'm not sure why we need to do this math here, but then we actually transfer. This is a deposit operation, right? So the next thing that happens after we update the pool is it does a safe transfer from for the liquidity pool token, which we can see it's identified by contract name here. So Uniswap V2 pair, that's just the name of Uniswap's contract. For every liquidity pool, it's the same contract name, but it's this one. And that corresponds to pool number 11, right, from this transaction. And it transfers it from this person. Presumably this is the person that initiated the transaction. And it transfers the liquidity pool tokens to 0xC2, which again is MasterChef 0xC2, right? So what happens when you deposit is SushiSwap takes your liquidity pool tokens. So this goes out, and this is where it gets a little bit complicated because we go first to safe ERC20, which is OpenZeppelin's wrapper. This does a function call ultimately to, what's this one? This address, that's 0xC2. That must be some other proxy. I'm not really sure what that is, but then ultimately what happens is we make a contract call over to the liquidity pool token itself, right? This is that Uniswap V2 pair. Sorry if this is hard to see, maybe I can zoom out a little bit. Haven't figured out how to make these diagrams readable. And that invokes a transfer from, oh, I guess we could see it at the bottom here. That invokes a transfer from, which then does a transfer. And you can see that OXC2, that's MasterChef. MasterChef stole, well, was given the LP tokens. And then that's it. That's the end of the transaction. So that returns. There's a little bit of a bug with the lines, but that returns, and then that returns, and that returns, and then we're all done. So in general, I'll summarize the basic process of doing a deposit to MasterChef involves an initial call to update the pool, which does two sets of minting. It mints for the dev share, it mints for the overall pool, the user pool, the issuance. And then it goes and it transfers the liquidity pool tokens from the sender of the transaction to MasterChef itself. Hopefully that helps. Is interesting.
The ownership of the liquidity pool tokens is transferred, and anybody can draw all sides, both sides of liquidity from actual Uniswap protocol pools, right?
Right. Well, the liquidity pool token confers the right to withdraw liquidity. So by MasterChef transferring from the sender to itself, effectively only MasterChef is then privileged to withdraw that liquidity.
Yeah,
right?
but just to highlight, this is a very common Solidity pattern. If you look at the Synthetix rewards contract, it's the Unipool contract. This is exactly the same pattern. People call it stake. You stake your liquidity pools, you get rewards back from it. So in most of the liquidity farming programs, you're going to see this exactly same pattern being used.
Gotcha.
I have a generic question more for like Uniswap, but like I think some of the menu included token like Curve, which was it Curve or some other, like it have its own governance token, right? While they're on liquidity, who gets the minted token? Like if we or Curve, they mint Curve token and all that stuff. And if we put
that depends on the rewards one. If you're using Unipool, Unipool itself grants you stake your liquidity pools. Unipool is going to calculate how much you have of rewards based on the time you have it staked and the rewards period. Then you can withdraw the rewards from as you know you've staked.
I mean, like if you put like ETH or something, it's like, you know, I don't know, Aragon swap or something, like it just normal token, yes, that's how you get the liquidity. But for example, if you put BAO or comp into the Uniswap, if my understanding is correct, by holding these token, was it holding the token or
no? That's not only holding. If you have balancer pool tokens, you can go for it. You stake them, then they go into Unipool, and Unipool is going to calculate the rewards for you and give it back to you when you ask for it.
So if you put like all these Gov token, minting token into Unipool, you do have an opportunity loss because you are not staking.
No, Unipool is what generates the rewards for you.
Yeah, that's for the Unipools.
Almost everyone. This is a contract initially done by Synthetics.
Yeah.
That's also used by Balancer. It's used by us for our liquidity mining program. So it's an extremely common contract. If you just look at, that's when usually people are doing their own research. They are taking like Unipool contracts. They are diffing it, and see if the only thing has changed are the tokens.
Yeah.
If there's anything else, they can take an assessment of that, because Unipool is usually considered to be safe.
Right. Okay.
Unipool is a smart contract that's responsible for the Uniswap pool management, or
no. It has this name. It's responsible for Synthetics rewards for liquidity programs. That's just the name of the contract.
And it's delivered by someone anonymous, or it's delivered as part of the solution?
That was developed by the Synthetics team and has been audited by quite a few teams, I think including Troy of Bits.
Is this the one used by YAM as well, or is it different?
I'm quite sure that YAM was using Unipool as well.
Yeah, I can't remember. Cool. Okay, thank you, Nick, for sharing the visualizer. Do you still do it manually, or that using Truffle you can just auto-generate?
I made a script that would run Truffle debugger and collect the information that it needed. I want to release this, but I think it's going to have to be moved into the debugger itself as functionality for the debugger, which means it's now in the hands of my engineers.
All right, that's super cool.
Yeah, I'm really excited for it.
Yeah. Okay, I can also do a quick show of what I've done. So I'll just, where is it? Yeah. So now I'm gonna share. Yeah, what I did is very, very super simple stuff. So probably many people, now I can't see everybody's face, but has anyone used like a Dune Analytics?
Yep.
Yeah. Oh, who hasn't used Dune Analytics actually?
I haven't used it.
Huh?
I haven't used it.
Okay, yeah, so I'll just do the quick intro. So now you can see my screen, right? Yeah, so Dune just gives you this kind of cool visualization dashboard, and it's quite cool that, so each of them you can actually, so what I did is I looked into the, let me check. I think I just cloned the, I do have the repo. And in the contract, MasterChef basically has, so now for those you who haven't looked into the contract, now you can see all these deposit, like, deposit and the withdraw, which is calling update pool and all that stuff. What I looked into is that I think I just looked into the this deposit, and so first one is just like I look into the contract of the MasterChef, and actually I think it's much easier if I just show the query. So you can see that basically SQL query. And what I did is like this one is super interesting, easy that, so Dune mostly indexes events. So like if you go to Sushi swap, no Sushi, yeah, Sushi MasterChef. So all indexes all the event information. So like yeah, transfer, deposit and withdrawal events. And if you look into that, so if you do select stuff from that. Can you guys read actually? I'll make it a bit bigger. Limit 5 was 4 or something. And if I run it, table, it shows you all these event information of the withdraw event. So the first half of the swap is I basically look into that events. Yeah, let me go through again. I think, yeah. Here, I just did the daily, I think I did, yeah, daily aggregation of the deposit and withdraw. And if you do the deposit sum and withdraw sum, that should show the liquidity of daily. So I just like created that. And also using, so these are the pools. And as I said, 11 is actually YFI. And these, if I want, for this one, I just hard coded. But if you actually, if you look into the Uniswap, most of the Uniswap events are also indexed in Dune. So you can actually do the join with the liquidity provider information. Then like if you look into the pair, you can actually look into each token pair. So you can actually derive that information. But like that creates a crazy number of joins, and it looks like super confusing. So I just like hard coded. And yeah, it just, and also I just did a cumulative one. So it just shows the growth of each LPs. So what you can, I'll just go back, what you can see that like initially, so this left and the right is exactly the same. It's just like, one is like absolute number and another one is like 100% ratio. So when you started, people, I think there's only synthetic S and there's some like die S and those couple of stuff. But as the day progressed, people started adding more stuff. And for some reason, a couple of days before, the huge chunk came from the YAM. But I think I'm not quite sure what does the amount of the LP token represents, but because each one token of the YAM and each one token of the state is not the same US dollar amount. So maybe I had to do more. This is just like a proportion of the LP token number. But to get the USD value, I think I had to do lots of join with the Uniswap and to derive for the token value to see the actual value.
They all paired with Ether, so maybe if you priced in Ether.
Oh yeah, that's true. But like if it's pair, yeah, that's true. Then does that like it then actually represents ETH value? I'm not quite sure. This proportional.
What does it look like? Because you have 2 million in some place, like 4 million DAI. Probably
Yeah,
it's in
but
DAI.
like I mean, the actual figure aside, if you look into the percentage, does it actually still represents that like YAM has like actually more than 50% of the entire LP pools? Does that actually mean like so many people put YAM in from just 2 days ago? It could be like different. Yeah, 40 million may not mean 40 million ETH, but does that mean like at least YAM is a dominant right now? Because this was kind of surprising because I didn't really see YAM until the very recently. So these LP growth and LP ratio came from like events. And another thing I wanted to track was that I was actually thinking about going for the sushi farming, but then like that week, like gas prices went crazy. And so I wasn't quite sure how much I'm going into. Like nowadays, like whatever you do, you get surprised by like, whatever the token transfer. First, you can't really see how much it costs until you approve, right? So you already spend like $4 or $5 approving. Then after that, I tried to transfer and oh shit, that costs like $60 to like, exchange like $10 worth of token or something. So I wanted to see how much it's going to cost for the gas price. So that leads to the second graph of a lot simpler one that Dune actually gives you Ethereum, I think transactions. Yeah, it has a whole list of transactions. So now what I did is this is a MasterChef contract, and I did the same aggregation, but I also create a map of the function signature for the most well-used one, like deposit withdrawal, emergency withdrawal. Migrate only happened once and it got canceled, right? So it doesn't really show. But like then, yeah, you can. I did a group by basically, so that it shows in the maybe that like for each functions how many calls has been made and also how much gas people paid. So like the 2nd of the September, at certain point, some people pay like $60 to deposit, but like most of the time, like when it was popular, it was like $30. And that was actually also like until Chef Nomi start dumping, it was always like more deposit than withdraw. But this is the time like when he dumped, and suddenly people just like withdrawing as well. So I was actually seeing this in the live, so that was quite cool. And another thing is like whenever there's a slippage or something, whenever people get in panic, transaction go fail. One thing So like many of the data analytics, I like using the graph protocol and all that stuff. But one thing graph doesn't, I don't think it necessarily shows is like it also shows you kind of whether transaction failed or not. So I was also mapping like how often these transaction call fails versus successful. Yeah, I did. And this one actually, the last half is, I do exactly the same thing for ENS when I was tracking for the ENS daily volume. So all I did is I just changed the contract address and the function signatures. That's it.
Wow, this is very cool.
Thanks. Yeah, I really like Dune Analytics. Like again, like I like subgraph as well. I like anything related to data in general. But in case of subgraph, unless you create like test environment, it usually takes like a few hours or sometimes like a days to actually index to start analyzing. And also, I think graph is good if you want to tie into the API and they do something. So like in case of ENS, when we list like a number of the names you own or something, you use graph. You have to use graph. But when you are just diving into the data set and to see what's happening, it's very strong tool, and that it doesn't really track all the events. But like if you request, I think MasterChef, the sushi content was already there when I looked into it. But most of the time, like for example, the token information wasn't there, like a sushi token. So I sent a request, and they just added like on Monday. So yeah, this I really like. Again, that's it. I think I'll start. Did I stop now? Share. Yeah. So are there anyone else there's things you want to discuss, or there's something like we can dive in collaboratively like together or anything?
For next week
The
or
code
today?
itself.
Oh, sorry.
The code itself, maybe.
Oh, code itself. Which part do you wanna know? I can share the screen again.
We'll start with MasterChef, which is the
Who started MasterChef?
withdraw. Yeah, maybe start with the post and withdraw, and we can go into the update pool. It's probably the most interesting part.
Oh, sorry, you mean who was the first transaction?
No, probably start with the post and withdrawals, and we can go into update pool, which is the core of the logic.
So in withdraw, you have to pass PID and amount, and first you just check like if user has any amount, and it does update pool stuff, which calculates stuff. Then you just transfer. I think this is similar. This is kind of where Nick's graph was showing. Mm-hmm. And do you want to look at update pool as well? Update pool. Yeah, I haven't really looked this in. Nick, can you explain a bit, like given you look into it?
Yeah, so update pool. Let me find it in my diagram. So update pool, first it does get multiplier. Well, I guess first it checks the balance. Oh, my diagram was missing that. So it figures out the supply. And this is to get the block, because every block there's 1,000 sushi, so that's 1,000 sushi per block total across all pools. So I think what's happening here is we figure out how many sushi to award to this particular pool. Is that right?
And the check if block number is less or equal than last reward block, it's just a safety. Really, it can be only check if it's equal, right? Because it can never be lower than last reward block.
Oh no, like if you are the first transaction to Master Chef in the next block, block.number will be greater than the last reward block.
Yeah, but can it ever be lower? No, right?
No, it will return, right? You don't want
No. I say, can it ever happen in the contract that the block number will be lower than pool last reward block? I guess not, right?
Oh, well, let's hope not. Yeah, that's a good point. But it might be equal, right? If you send two transactions.
Yeah, I think it might be equal and someone just coded for safety less than equal. Just
if the supply was equal to 0, was not equal to 0, then the last rewarded block wouldn't be updated. Oh no, you would, you update it later. So obviously, if somewhere there was a logic where the last rewarded block wasn't getting updated, then the block number would be higher.
yeah, what happens here if supply is 0? Okay, it just returns immediately by saying I calculated rewards immediately, they are nothing, right?
Right. And then it figures out what the multiplier is based on the last reward block and the current block.
Yeah, and this is why it's doing the double minting, right?
And there's the double mint.
So altogether it does 110%, right?
Right. Yeah.
That's why you're saying 9% goes to.
Right. Right. Yeah. Chef Nomi said 10%, but it's actually 9%, and that was reflected in QuantStamp's audit.
It's interesting because it clearly means that they were planning 10%, but I didn't calculate it properly, which is a bit depressing.
They only got $13 million. Not.
Yeah, for not being able to calculate the percentage, right?
So after the audit, did they redeploy, or no, they just left as is actually?
They left as is. There weren't. I think the biggest vulnerability that QuantStamp identified was some issue with the delegates, but I didn't really figure out what that meant.
The delegates need to be in the sushi token contract. Yeah, now you can see the delegates, they're going to appear again, I believe, at the checkpoints.
This one?
Yeah, so the checkpoints, the structure that it's essentially a structure that marks block number and balance. If you look, this is a very common structure. I think it's done by the Giveth guys for DAO governance, which you want to know at a given block number how much you had in balance. So instead of doing this off-chain with an indexer, you keep the state in contract. So when you move delegates, you don't change the balance, but you're changing the checkpoints, which is the effective balance for voting for a given contract, for a given address.
Can you explain it more in details? Maybe I didn't get it fully, but
Sure,
maybe if everyone else understands it, I can just follow some links.
That's Makoto. Can you go up and show the structure of the checkpoints?
What do you actually want to show, and do you want to drive now?
No, it's all right. If you
Yeah.
just show the structure of the checkpoints, the definition of checkpoints.
Where was it?
Yeah, it's yeah. So as you can see, for each address, you have per block or per index, like per historical time that the address has changed. You have this last checkpoint, which means at a given block number, you had this amount of balance. And if I can't delegate, this essentially is the time series of my balances, right? And I want to know at a given block number, at a given block height, I want to know how much you had. And I'm not going to trust an option index to do that for me. I'll get this state from the contract itself. So you can actually calculate everything on chain. Now, if I have delegates, checkpoints are no longer equivalent to balances. Checkpoints are equivalent to the effective amount of votes I have, which are my voting tokens plus the delegates I received minus the delegates I gave. Does that make sense to you? Yeah, if you look at Gifford, Aragon, you see this pattern repeats in many Solidity contracts.
It practically stores the historical values, as you say, time series inside the contract instead of trying to reach it in different places.
Yeah, because if you get this from an external indexer, you can't do this calculation on chain. I can do a DAO vote considering the amount of tokens people had at a given block height. I need to have this information in the contract itself so I can calculate it that way.
And it is it keep
Thanks, that
appending
explains everything.
checkpoints?
Mm-hmm.
Is it keep appending like your old checkpoint?
It doesn't really append because it's a mapping. So it allocates everything on contract deployment.
I see. And do we understand how does this get to the vulnerability?
No, I didn't read the timestamp report.
Yeah.
So
Maybe that's a bit difficult to dissect in like 5 minutes or something. Yeah. I think we have another 5-10 minutes. Are there anything else you want to explore together, or any questions? Or
I see we were analyzing this move delegates on 0 to 0 address, but there is a check here that returns immediately if the from address is equal source address.
yeah, which kind of makes sense, right? Because if you look at the mint, the underscore mint function, it actually just calls move delegates from source to delegates of 2. So it's not checking if you actually have a delegate. So yeah, it makes sense the check to be somewhere else.
Thomas, do you have any more questions? Like I still don't fully understand, to be very honest.
Yeah, I think I'm gonna have to sit down and make sense of the delegate stuff, checkpoints. That it's not a 5-minute and you understand it. I think.
Maybe
I looked. Yeah, I looked into this for Pillar DAO, so that's why I know that I've seen this stuff before.
I see. Yeah. I mean, if there's any finding, you guys can post to the Telegram channel after this, yeah, always hard to just understand everything in real time. But I can publish the video so you can just watch through later. Okay, anything else? Cool. Yeah, so this is kind of how we do in the co-op stuff. Probably I'll try to do it either every week or every other week. So like if you have any other, I've been thinking like, I want to do more diving on the Yarn finance, but then like every week there's new hot things hopefully coming up. So we get like diverted. So like we could focus on Yarn, or if there's anything you guys interested, we can talk about it. So just keep suggesting in the Telegram channel, and I might just try to reach out someone from the dev team. I think Yarn team did some update on the new team members, so it would be great if we can bring someone who's actually writing some of the code. I asked Andre a couple of times, but he seems busy. So if we can bring these developers, I think that would be even better, because we can have even more discussion. So like if there's any DeFi related one, if you know some devs who know more about this code, please like invite them as well. Okay, so that's it. Yeah, thank you very much, guys.
Thank you. Bye bye.
Yeah, thank you for organizing.
Thanks, all guys.
See you.
Thank you, everyone.
Yeah.
Bye-bye.
Cheers, bye.
Thank you.